Welcome aboard, fellow space travelers. I am absolutely thrilled to be your captain and guide today. Go ahead and strap yourselves in. Take a look out the window of our imaginary spacecraft and get ready because we are diving into an epic explainer today. We're going on a quest to really grasp the true scale of our universe. Seriously, it's a grand voyage across the cosmic ocean, so let's get right to it.
All right, as our ship slowly drifts up out of the atmosphere, I want you to look back out that window. See that fragile sphere of blues and greens cradled right there in the black void of space? That's Earth. It's just this tiny blue dot, right? But think about it. Right there is everyone you've ever known. Every human who has ever lived, and literally every single story that was ever told. It's where our journey begins, and honestly, seeing it from this vantage point, it just instantly puts our entire existence into a profoundly humbling perspective.
Log entry 1. Leaving our home planet. Okay, let's dive into this. I'm setting the ship's coordinates for the very first marker on our cosmic journey, the Moon. Now it sits about 384,000 kilometers away from us, which is a distance that already kind of starts to test our earthly comprehension. To give you a real sense of what that actually means, imagine pointing a car up at the sky and driving at a constant speed of 100 kilometers per hour. It would take you over 160 days just to reach the Moon. But as we look further out to our sun, that fiery behemoth giving us all life, the scale just completely explodes. The sun is 1 astronomical unit away, which is roughly 150 million kilometers. If you hopped in a standard commercial jet flying at 900 kilometers per hour, reaching the sun would take you about 19 years. 19 years! This astronomical unit is the standard measuring stick for our solar system, a place where even light, traveling at an absolutely astounding 300,000 kilometers per second, still takes 8 minutes and 20 seconds to make the trip.
Log entry 2. Crossing the solar system.
So, venturing beyond our home planet and its solar companion, we're now setting our sights on our enigmatic red neighbor, Mars. And here's the thing we quickly realize. Navigating space isn't just like driving down a straight highway. It's much more like a dynamic, moving dance. At its absolute closest approach to Earth, Mars is about 54.6 million kilometers away. Pretty far, right? But when our two planets happen to be on opposite sides of the Sun, that distance can stretch up to a staggering 401 million kilometers. If you were to take that same commercial jet we talked about over to Mars, it could take upwards of 50 years to cross that expanse. This constantly changing distance, these really complex orbital dynamics, well, they are exactly why space exploration is such a monumental challenge for all the rovers and probes we send out there.
Now flying much, much deeper into the outermost reaches of our solar neighborhood, we run into Neptune. Just look at this distant ice giant. We are now roughly 4.5 billion kilometers from Earth. And the sheer enormity of our solar system really starts to sink in when you realize that sunlight, which took just 8 minutes to reach Earth, remember, has to literally race across the cold vacuum of space for about 4 hours and 15 minutes just to touch Neptune.
As we drift out here in the quiet dark, we're actually following in the footsteps of a silent wanderer, the Voyager 1 space probe. Launched way back in 1977, it's now over 22 billion kilometers away. It is literally the farthest human-made object from our planet. Back in 1990, at the suggestion of the legendary astronomer Carl Sagan, Voyager 1 turned its camera back toward Earth from 6 billion kilometers out, and it captured the iconic pale blue dot photograph. In that image, our planet appeared as just a tiny, faint speck in the vastness of space. And as Carl Sagan so beautifully put it, Earth remains a small speck in the immense universe, emphasizing our shared responsibility to cherish and preserve our only home.
Log entry 3. Entering interstellar space.
All right, our ship has now arrived at the Oort cloud, which is this vast theoretical sphere of icy objects extending up to 100,000 astronomical units from the Sun. We are officially crossing the heliopause. Right here, the Sun's solar wind is finally stopped by the interstellar medium. The Sun's influence basically wanes and true interstellar space begins. Out here, our ship literally needs new navigational metrics. As we target our next point of interest, Alpha Centauri, the closest star system to our Sun, we are looking at a distance of 41.3 trillion kilometers. That is over 276,000 astronomical units. Because the AU loses all practical meaning at this kind of scale, astronomers have to upgrade. We switch to using the light year, which is simply the distance light travels in one single year.
So, using our new metric, Alpha Centauri is 4.4 light-years away from us. Now, to truly understand the colossal challenge of interstellar travel, I want you to look at this number, 70,000. With our current space travel technology, a journey to our neighboring star system is, frankly, almost unfathomable. Even if we were traveling at the speed of that Voyager spacecraft we just talked about, which, by the way, is a blistering 17 kilometers every single second, it would still take over 70,000 years just to cross the vastness of space separating us from Alpha Centauri. No way around it, that is a long trip.
Log entry 4, our galactic neighborhood.
So, let's open the throttle and pull the camera way back. We are now gazing at the grand scale of our home galaxy, the Milky Way. It's a vast spiral spanning about 100,000 light-years in diameter, and it's absolutely packed with hundreds of billions of stars, each potentially hosting their own planetary systems. But the most crucial and honestly sobering point is captured right here with this number, 100 light-years. You see, within this immense 100,000 light-year-wide spiral, there is a tiny little sphere known as the human radio bubble, extending just 100 light-years from Earth. This is the absolute farthest extent of human influence in the cosmos. It's the maximum reach of our radio and television broadcasts. Beyond this tiny bubble, well, it's as if humanity never existed. Any civilization residing in the vast majority of our galaxy would be completely oblivious to our presence. Our entire recorded history is just a whisper in the cosmic wind, totally undetectable outside this small radius.
Log entry 5, the superclusters.
Leaving the Milky Way entirely, we must now lower our voices as we enter the silent wilderness of intergalactic space. This is a vast, frankly incomprehensible realm where whole galaxies float like islands of light in a dark cosmic ocean, separated by mind-boggling distances. Let's see how this builds, step by step, across these cosmic giants. First, our Milky Way is really just one part of the local group, which is a cluster of over 50 galaxies spread across 10 million light-years. Light itself would take 10 million years just to cross it. Next, we zoom out to step 2, the massive Virgo supercluster. This encompasses our local group, plus thousands of other galaxies from at least 100 galaxy groups. It spans 110 million light-years, or 33 megaparsecs in diameter. And finally, we step out to a structure so staggering it honestly defies imagination, Laniakea, stretching over 500 million light-years across.
Laniakea translates to immense heaven in Hawaiian, and boy does it ever live up to its name. This is our true galactic home on a grand scale. It contains the mass of 100 million billion suns. It's an absolute gravitational masterpiece. And right at the heart of Laniakea lies the Great Attractor. This is a mysterious region of space exerting a massive gravitational pull, binding countless galaxy clusters and superclusters into this majestic cosmic web of attraction and motion. In this gigantic supercluster, our entire Milky Way and the Virgo supercluster, they're just tiny, minuscule components.
Log entry 6, the observable limits.
Finally, fellow explorers, we have arrived at our ultimate destination. We are now standing at the very boundary of our cosmic exploration. I want you to just take a second to really look at this number and let it wash over you with a sense of utter awe. 93 billion light-years. That is the staggering diameter of the observable universe. This astronomical marvel literally dwarfs absolutely everything we've talked about on our journey so far.
And you know, this actually brings up a really fascinating paradox. Think about it. How can the observable universe be 93 billion light-years in diameter if the universe itself is only 13.8 billion years old? I mean, shouldn't light have only had 13.8 billion years to travel? Well, the answer lies in the sheer nature of cosmic expansion. Ever since the Big Bang, the universe hasn't just been sitting there statically. It has been actively expanding, literally stretching space itself and increasing the distances between all celestial bodies over time.
Which leaves us with the ultimate question as we wrap up our explainer today: what lies beyond the observable universe? Honestly, this remains one of the absolute greatest mysteries of cosmology. Because space is expanding away from us faster than the speed of light, some regions are placed forever out of our view. The true size of the entire universe remains totally unknown, and hey, it is potentially infinite. Our vast observable universe might just be a tiny fragment of the whole shebang. It's a deeply humbling realization that as we look out the window of our ship today, there might always be wonders, entire galaxies and vast regions of space that we will never ever witness as they retreat endlessly into the depths. So, what do you think is out there in the dark? Keep looking up.